Oppenheimer, Superman or Super Lucky? The new Christopher Nolan film Oppenheimer and the current proxy war between the U.S. and Russia in Ukraine, with loud talk about the use of tactical and perhaps strategic nuclear weapons, has brought the Manhattan Project, which developed the atomic bomb in World War II, into the public consciousness more than in many, many years. How much of it was luck, and how much of it was the product of the enormous funding, organizational structure, and other factors which we can control and duplicate? Every year we hear calls for a Manhattan Project for climate change, for cancer, for a wide range of problems. In this video, I'm going to talk about how the history since World War II shows that most new Manhattan projects fail, and explain why the Manhattan Project was probably, quote, lucky, unquote, a bit of a fluke, probably due to the unusually cooperative properties of the new materials, uranium-235 and plutonium-239, discovered as part of the project.
In this video, I'm going to talk about the wartime Manhattan Project, which developed the first atomic bombs, which were dropped on Hiroshima and Nagasaki in World War II. This was a spectacularly successful scientific R&D project. It created the idea that there was a sort of a management formula for these big science projects, government-funded, huge armies of people, quasi-military structure. The Manhattan Project was run by a general, Leslie Groves, who oversaw the construction of the Pentagon, amongst other achievements. That we could reproduce this in a new kind of science that was huge, and it would work. It's inspired numerous programs, many of which, actually a large majority of which, have largely failed in practical terms. Extreme examples are the war on cancer, which has consumed something like $200 billion and currently has an annual budget larger, adjusting for inflation, than the Manhattan Project. These programs usually fail. The folklore tradition, which is borne out by reading and research and so forth, is a failure rate of around 80 to 90%. In this, I'm going to talk about how the Manhattan Project was very unusual for major scientific breakthroughs, inventions, and discoveries. If you look at other cases of really dramatic things, the discovery of flight, for example, the Wright brothers, many, many different both scientific and technical inventions, it's unusual in the number of discoveries that they're made and sort of productized, made into working practical things. And in particular, the bombs worked right. The first bombs, according to the official story, actually worked right the first time. They blew up. The Trinity test in July of 1945 was successful. The bombings of Hiroshima and Nagasaki, which were essentially prototype weapons, blew up. They weren't duds. They didn't do something really unexpected. And in fact, many subsequent tests were successful in the sense that they blew up. In fact, some were more powerful than anyone expected, rather than, say, being duds, which you might expect. That's remarkable. It's unusual in the history of major inventions and discoveries. There's normally large amounts of trial and error. Normally, the full system tests fail the first time. In fact, there's a lot of trial and error before they start working the way, like when you go buy an iPhone today, it works really, really well. Okay, or you do other things today, they work really, really well. That's a product of many, many years of trial and error, lots of failures and problems in the early days, which go on for years. The Wright brothers' first flight was in a high wind, which made it easier in 1903. Got a few hundred feet, barely successful. It took them 5 years to 1908 before they were able, after many, many tests and crashes and other problems, they could fly reliably for a few miles. They were eventually able to demonstrate their flight at a fort to a large audience and prove they were able to do what they were doing. There's huge amounts of trial and error that seemingly you don't see in the Manhattan Project, so it's very unusual. This is important to understand. So I'm going to talk about in more detail how unusual the Manhattan Project was and go into more detail on that. I'm also going to present the probable reason why it was so unusual, and this is not typical. And again, subsequent programs have repeatedly failed. They can't reproduce this success. The physicists themselves in programs like controlled nuclear fusion, and in fact, various weapons development things, and in particle physics, which I got my Ph.D. in, have been unable they've stagnated, they've plateaued, they've been unable to reproduce the success they had with the Manhattan Project. The likely reason for that is the unusual characteristics of uranium-235 and plutonium-239 hit a sort of engineering sweet spot where it was relatively easy to get the bombs to work. It was relatively easy compared to other major inventions and discoveries, relatively easy to do the theoretical calculations that they actually happened when you set off the bomb. It actually worked according to theory, which is atypical of most major inventions and discoveries. These materials had very unusual properties that are unusual in major discoveries where maybe you have a new material that you're trying to figure out how to use. Furthermore, for some reason, they were remarkably safe in the sense that we don't have ICBMs exploding. We don't have these things blowing up. Even though they're sort of easy to get the bombs to blow up, they are relatively safe, and we don't have ICBMs at launch facilities blowing up. We don't have Los Alamos totaled every couple of years because of a nuclear physics experiment or a bomb experiment went wrong and the whole facility got fried. That doesn't happen, unlike, say, with nitroglycerin in the early days of explosives. But two things. The Manhattan Project was very anomalous and unusual for major invention and discoveries. We've not been able to reproduce that. And secondly, the likely reason for that, I will explain. Although it's possible the official story is substantially wrong or in error or fraudulent, and the reasons are different from what I present. But again, I will present the most likely reason, which is special, so we lucked out with the properties of uranium and plutonium, creating an anomalous example that's been led to inflated expectations of people really expecting something that was really an outlier, a freak. So let's talk about what was unusual about the Manhattan Project. The official history of the Manhattan Project that we have makes a very remarkable assertion, okay? It's so remarkable that I have to wonder if that history is actually correct, okay? And what I want to say is here, I'm basically going to accept as given that the basic history that we have about what happened in the Manhattan Project is roughly correct. Of course, history is never perfect. There's always fuzziness, recollections differ. When there's a big success, everyone wants to take credit for it. But the official history is the atomic bombs worked right the first time, okay? And they worked really well. So the first bomb, according to the official history, is the Trinity explosion in July of 1945, supposedly a test of an implosion plutonium bomb. The way they often describe it is, well, it was such a difficult thing. We had all these brilliant people like Feynman and Hans Bethe and his little team, and they did these theoretical calculations that the thing was going to implode. And they thought maybe we should actually test it before we actually drop it on somebody, right? That's what they say. So they did a test, one test, and supposedly spectacularly successful, lights up the sky, all that kind of stuff, right? It is followed by two bombings in Hiroshima and Nagasaki in August. Supposedly one of those bombs, actually the uranium-235 based bomb, that's supposedly the first one that's ever been detonated, blows up an entire city, burns it to the ground. Second one is a plutonium bomb, Fat Man. I'm pretty sure that's the second one. Anyway, this is the one that Trinity was supposedly a feasibility test to make sure that it would work. And astonishingly, it works right the second time. It's not a dud. It doesn't sort of half measure. They drop it, and it smashes through the church or wherever they dropped it. They actually dropped one of them on a church. The point is, they work right perfectly the first time. They cause enormous destruction. And this is the way the atomic bomb program continues to be described. The official story, as far as I can tell, is there's never a dud. Every test, the things blow up. In fact, in a couple of tests, they blow up much worse than expected, a much bigger explosion. There's this notable story of Operation Bravo, where they supposedly tested the first solid state hydrogen bomb. So it used lithium hydride to provide the deuterium and tritium for the bomb. It's a technical point. But this bomb actually blew up way more powerful than they expected. And they were like, oops. The point is, this is actually very, very unusual in major breakthroughs and discoveries or any R&D. Usually your first attempt flops. Usually your 10th attempt flops. Many people may have heard the story, of all of the light bulbs that failed for Edison. Supposedly there were like 10,000 of them. He tried and tried. He had this team. They were trying and trying, kept failing and failing and failing. And you would get criticism, well, you're not working. So no, we're learning how not to build them. But this is not unusual when you look at the history of major technological inventions and scientific discoveries. There's enormous amounts of trial and error. It's not unusual. It's the norm. It's the most consistent pattern that one finds in looking through major inventions and discoveries, breakthroughs like the atomic bomb. Why is that significant? Well, usually when people build some new thing, it doesn't work right the first time, and it takes a lot of trial and error to get it to work. And this has been true of weapons as well. Gunpowder, for example, was known hundreds of years before it became militarily useful. There are all kinds of attempts to build cannons, and they blew up, right? You put the gunpowder in, and of course, it's not trivial to make the original. It's a mixture, the original gunpowder, the black powder. It's not what we use today, but the original black powder is a mixture of sulfur and saltpeter and charcoal, and it has to be machined, and all sorts of stuff has to be done to make it actually explode correctly. But okay, you make the gunpowder, right? You pack it into your prototype cannon, and guess what happens? The cannon blows apart. It's not trivial to produce a cannon with the metallurgy that works. Right? Explosives took a long time to develop to be effectively useful. That's important to understand. So for these bombs to work right the first time is really remarkable, based on basically theoretical calculations supposedly by this little team of physicists. This is part of the mythology, right? Headed by Hans Bethe, and included Richard Feynman, then like in his 20s, and other famous people aren't as well known as Bethe or Feynman. And it works right the first time. Trinity blows up, everything works, great. That is very abnormal in major inventions and discoveries. And in fact, it's unusual to see so many inventions and discoveries made in a 4 or 5 year program. So we have plutonium is discovered. They figure out how to mass produce plutonium. They don't just discover plutonium. They figure out how to mass produce it in explosive quantities. They somehow figure out how to make large quantities of uranium-235, which is a trace component of normal uranium. A lot of major successes in this one program. And it works right the first time, and it keeps working. And consider, and I'll talk a little bit more about how perhaps it's that the specific properties of uranium-235 and plutonium just happen to be unusually cooperative compared to, say, gunpowder or early explosives or steam engines or a lot of other major inventions. And that may be why. It's just that they lucked out. It turns out these materials are in a real sweet spot where, one, it's easy to build a bomb, but somehow, even though actually it's not that hard to set off a nuclear explosion once you have the purified uranium-235 and plutonium-239, okay? So you have to make these materials, and they're just very highly explosive, right? So you pack some of them together and they blow up. It's not that hard. You don't have to do the calculations perfectly, or the theory has to work. They just happen to work well. But strangely enough, you don't get bombs going off unexpectedly, right? If you have a highly explosive material, right, that's pretty easy to detonate, right, to set off, and I'll talk about this more, then you would expect the bombs in our ICBMs and on submarines and things to be blowing up occasionally, right? Things would go wrong. Or at labs like Los Alamos, they've got some of it lying around and somebody accidentally pushes it together. No, the official story is it actually is fairly hard to get it to explode. And yet the things explode, right? The first time, the second time, and over and over and over again. That's a sweet spot. That's a very unusual situation with machines, with materials, compared to other inventions and discoveries, if true. That may be true. I can't rule that out. Now, people have raised questions. There are some unorthodox theories which don't really answer the question I just raised. So this is an example. This is an alternative history, if you will, of the development of the atomic bomb, which claims the Nazis actually purified uranium-235 and the explosives from it were in a deal, given to the United States in exchange for various, things. And, this is actually where the explosive material for the bombs that were used in Hiroshima and Nagasaki came from. I'm rather skeptical, but I just want to point out there are people who have questioned the official story out there. I'm not actually questioning the official theory in what I'm talking about. I'm just raising that possibility that there's reason to be skeptical that what we're told is correct, largely correct. They haven't omitted a major key point or lied about a major key point. Okay, so just keep that in mind. So we can argue that very clearly from experience that what we see with the Manhattan Project, with these weapons working perfectly for most practical purposes the first time, was clearly very unusual. It's not what you see with steam engines. It's not what you see with rockets and aviation. You see repeated trial and error, and the full system tests, setting off the bomb or trying to get that first cannon to work, doesn't work. It takes a lot of trial and error, something that supposedly did not happen at the Manhattan Project. Why? As I said, one explanation is it's a very anomalous case that uranium-235 and plutonium-239, that really the key thing is to get these materials in large quantities, that they're actually pretty easy to work with and produce an explosion. And yet, they also don't actually present a large risk of the explosion happening accidentally while the in a nuclear submarine or ICBM, as I said. Now, one of the things about these bombs, like the Fat Man design, the Trinity bombs, is they're supposedly a perfect sphere, or very close to I shouldn't say perfect sphere, but they're spherical. Okay, there's a joke about physicists, I'm not going to go through it, about how physicists are always modeling everything as spheres. It's called a spherical cow, right? They're talking about cows, and the physicist says, first, I assume a spherical cow. Well, it obviously doesn't work with cows. But with atomic bombs, these very simple mathematical calculations, remember, they didn't have supercomputers in the 1940s, that assume that everything's spherical, which makes the math a lot easier. Those assumptions are reasonable. And again, this goes together with the idea that plutonium-239 and uranium-235 just have some really nice properties from the standpoint of building your first bomb. It actually will blow up. And on the other hand, not having accidental explosions because it's a very explosive material. Remember, that's the problem with explosive materials. Nitroglycerin is very explosive and it's dangerous, right? We have dynamite, we have TNT, because the first explosives, okay, they got this super explosive material and it was blowing up and killing people accidentally all over the place. That quite clearly has not happened with uranium-235 or plutonium-239. So it's a very unusual situation. Unlike the black powder, which you have to actually work to get the right ratios and machine the powder, it's got to be fine and properly mixed and all these other things, which of course doing those things can risk blowing up in your face, right? Actually, somehow you can make uranium and plutonium a relatively easily, I'm using the word in quotes, compared to most major inventions and discoveries, not compared to everyday life, but compared to most inventions and discoveries. So if you accept the official history, the most likely explanation for this anomaly is that uranium-235 and plutonium-239, which are elements, have sort of this sweet spot. They have sort of just the right properties so you can actually succeed and get the thing to blow up relatively easily the first time, according to the official story. And on the other hand, you don't have this risk, like nitroglycerin has, of blowing up and killing everybody unpredictably. So you lose, Air Force bases, you lose, forts, you lose these launch facilities in the North Dakota and all of these things, they're blowing up because like nitroglycerin, it's actually easy to set the thing up. So they just lucked out and hit an unusual material, which had these unusual properties. And it was, again, in sort of this engineering and design sweet spot where you could actually be pretty successful. The theoretical sphere, assume a spherical calculations worked. The thing blows up the first time. And again, unlike nitroglycerin or other explosives, early explosives, the risk of blowing yourself up accidentally, turning Los Alamos, is actually, fortunately for those people and for us in any general case, quite low. That's very anomalous. I think anyone, if they really think about invention and discovery or machines you buy, and how many times have you bought the first one, right, and it didn't work right, and then a year or two later you buy a different one, right? You bought the first iPhone or something and it's full of bugs and has all these problems, right? That's what normally happens. And in major inventions and discoveries, it's even more prominent. It's usually a significant time lag between the insight, the brilliant idea that eventually turns out to be the right idea. The Wright brothers fly their plane like 100 feet or something in a high wind, in 1903. And when 1908, 5 years later, when they're actually flying repeatedly for miles at a time, and they can actually demonstrate the technology very reliably, it's still dangerous, but much more reliably than what they were doing in 1903. There's usually this large lag. There's usually substantial trial and error going on before you finally get to the point where like your atomic bomb blows up and destroys a city reliably. And it doesn't blow up and kill you. That's very anomalous. And it's important that people understand how anomalous it is. It's anomalous for major inventions and discoveries. And in major inventions and discoveries are very high risk undertakings in the vast majority of cases, as the Manhattan Project probably was. The official story is Japan, Germany, other people are trying to do it, failed. Somehow we got it to work.
In conclusion, was Oppenheimer Superman or super lucky? Of course, the Manhattan Project was far from a one-man effort, with many, many other people, allegedly up to 50,000 people involved, including many people who contributed to the technical development of the weapons, such as Enrico Fermi, Leo Szilard, Hans Bethe, Richard Feynman, and many, many more. Overall, the subsequent failures of so many new Manhattan projects and the history of invention and discovery, with the enormous amounts of trial and error and the frequent failures of full system tests, especially at first, all of this taken together suggests that there was an awful lot of luck, an unusual amount of luck, in fact, in the Manhattan Project, which enabled it to achieve an unusually successful major invention and breakthrough, which has not been duplicated in many subsequent efforts, such as controlled nuclear fusion, various particle physics projects, the war on cancer, and so forth. So while respecting the great accomplishments of the team that created the atomic bomb, we should also recognize that this is not a reproducible formula for success, and it is also an extremely expensive formula that has been followed unsuccessfully many times since the Manhattan Project. Perhaps it's time that the world move past the Manhattan Project and other memories and traumas from the Second World War. This is a brief credit to freepick.com for the military tank icon used in the slide on the Ukraine-Russia war. This concludes this video presentation. If you like this video, please click like. Please click subscribe and the notification bell if you would like to receive more content from us. You can avoid internet censorship by subscribing directly to our RSS news feed. Please consider sharing the link by email and on your website or blog, in addition to liking, upvoting, or sharing on increasingly censored, advertising beholden, big company social media. We have encountered such censorship. Mathematical software is developing algorithms and software to automate data analysis, reducing the risks of costly errors and increasing the predictive power of the results. You can support our work financially by subscribing on our Patreon page, https://www.patreon.com/mathsoft, or scanning the QR code in the lower right corner.